Strain bus calculation, I already showed you that. Wait a minute. Again, I will show you the strain bus in the substation. Yes. Team, are you able to see my screen here? Hello. Yes, fine. So you can see here, see, this is the one. We are having two towers. Between the towers, I am stringing a conductor like this. So this we will call it as a strain bus. This strain bus, you can see in this figure, see, it is moving above the equipments. These are the equipments. These are the equipments. Above the equipments, this is moving. This is laid above the some level of some level. So we have to, so we in our previous class, we discussed on the sizing of this bus bar. This is the rigid bus bar, like an aluminum pipe. But this we will call as a strain bus. In some regions, we will call it as a jack bus also, which is laying at some level. This bus is generally required and sometimes we will do this train bus like a main bus also, and in some projects, in some layouts, we require this train bus as a jack bus. So what is a main bus and what is a jack bus? So jack bus is generally we are what laying the conductor. We are laying the conductor at the topmost level of the substation for some layout connectivity. For the layout connectivity, suppose, let's assume, let's recall our single lane diagram, team. If you just recall our single lane diagram, we are having double bus at the 220 kV level. How this double bus is connecting? With the two isolators, and it is connecting to a transformer, a breaker, CT, this, right, and lightning arrestor. If you recall our single line diagram, so for 220 kV. Now, if I want to erect this same in the substation, how I want to do this? See, I will place the transformer, and I will place the lightning arrestor, and the CT, and breaker, and the CT, and this bus I have to do. I am laying a tower like this, two towers. On middle of these towers, I am laying a bus like this, right? In this way. And after that, isolator, and this isolator, and again this isolator is connected to this bus. This isolator is connected to this bus. But this one, this CT should connect to mid of this isolator. Should connect to the mid of this isolator. How it will connect here? So we cannot go like this because all these phases are in same level. So I have to arrange one more level of the conductor on the top, and I have to connect this one to this, and I will drop here. Again, I will drop here and I will connect to this as well as this. So depend upon the layout connectivity. At some cases, we require this kind of bus, which is not a bus in SLD. It's a kind of for connectivity. I am making a bus. So that bus we will call as a jack bus. So this jack bus generally will lay at some 16 meter level if I am talking for 220 kV, and 18 level or 20 meters level or 18 meters level for 400 kV, and in 33 kV at 11 meter level. So depends upon the layout connectivity and project specific, it will change. So this jack bus, again, what I am doing, I am just connecting the two, I am laying a conductor between the two structures. Between the two structures. How I am laying this? With some kind of insulator. With some of insulator. So what is happening here? So it's forming it is a conductor which will not be obviously straight, because this conductor is a bare conductor having some tension in this. So, and some weight, depends upon the weight, it will have some sag in this sag. So this sag may gives the may affect the clearances between this equipment and this one. So I have to ensure, I have to calculate the sag here to get the required tension as well as the support structures and also the clearances, whether I am meeting or not. For these three activities, I have to do the sag calculation. So how the sag will affect again? Sag will again depends upon the weight on that one. So weight in the sense, again, just recall our last session. We are talking about the short circuit forces, ice loading, wind loading. So these all as a weight now. These weights may gives the conductor to in this shape, catenary shape. So can be hanging. So which results in sag. May this sag will create a tension on these towers. If the sag is high, this tower will fall in this direction, this tower will fall in this direction, bend. So all these things we have to, only the sag is the one which affects all the other things. So if we calculate the sag, we can conclude the tension that to be applied. So if that, what is the tension? Suppose 10 kilonewtons of tension I am applying. So that structure should be capable to handle that tension. So selection of the structures will be completed. And after that, this sag may also gives the clearances, required clearances for the down conductor. So for everything, what we need to do, we need to calculate the sag. That's it.